Hi everybody, in this video we are going to solve a few trig equations. The directions are asking us to solve them on the interval 0 to 2 pi. So something like this one here, we already have cosine of our angle. You could think of that as theta if you'd like. Isolated equals -1. It's not a second degree equation. I don't need to get it equal to 0 to factor or anything. So really what you're doing is saying cosine of what angle equals -1. So I want to look over here. When you have a multiple angle, this is the situation where we have to use our general solution plus 2 pi n to find more answers. So that means in the next step, essentially we're taking the inverse here. 2 beta will equal cosine of what angle or angles equals -1. That would be pi. Again, we have a 2 in front of the beta. Plus 2 pi n, where n is an element in the set of integers. It just means n's an integer. Now, I need to get beta totally alone, dividing everyone by 2. Beta is alone equals pi over 2 plus pi n. So what does that mean about our solution set? One of our answers is pi over 2. If I add pi, that would be 2 pi over 2 being added. That gives me 3 pi over 2, and I'm still between 0 and 2 pi. If I add pi again, another 2 pi over 2, I'm at 5 pi over 2. That's too big, and I'm done. If you plug these back in, 2 times pi over 2 is pi. Cosine of pi is -1. 3 pi over 2 times 2 is 3 pi. Cosine of 3 pi is -1. Done. Okay, do it, redo it, whatever you need to do. Same idea here, same style. I have 3x as my theta. Sine of theta equals 1. So the sine of an angle equals 1. The sine of what angle equals 1? Sine of what angle is 1? Well, pi over 2. But again, when you have a number in front or with your angle, we solve by using the general solution to start. So normally we would write plus 2 pi n is an element in the set of integers. And now we're going to keep going and find all of them, but I'm going to divide by 3, which is the same as multiplying by a third, divide by 3, right? That means I get x equals pi over 6 plus, now 2 pi over 3, that's really 4 pi over 6, so I'm going to write it like that for now, n. Now let's make our solution set. If n is negative, I'll get a negative number, and I want between 0 and 2 pi. If n equals 0, then that falls off. I get 1 pi over 6. If n equals 1, I add 4 pi over 6 once. I get 5 pi over 6. If n is 2, that means I'm adding really another 4 pi over 6, or 8 pi over 6 in total, and I'll get 9 pi over 6. That is still less than 2 pi, which is 12 pi over 6. If I add 4 pi over 6 again, like a third time, 3 of them, then I'm adding 12 pi over 6, which is more than what I can, because that'll put me 2 pi, a whole extra. That'll be at 13 pi over 6, and then I'm done. If you reduce that answer by 3 on top and bottom, you get 3 pi over 2. But to be honest, for listing answers like this, I kind of actually, rare, I know, prefer that you leave them with the common denominator, because it makes it easier for me to grade and see that they're like properly spaced apart and all that, because you're going to be adding so much, especially when we start graphing and labeling the x-axis. This is going to be a lot easier. Okay, let's see if we can get another one or two done over here. Now, even though number 53 looks like you could just set each one equal to -1, like it's factored, you're not allowed to do that. Okay, so what we have going on here is tan half angle identity. And which one you pick to use, because we have options for that, right? We have 3 different options for the tangent half angle identity. I tend to use, like I've told you guys in the past, the one that kind of looks like a heart. I tend to use that. And I think it'll all work out pretty nicely for us. Let's see. Before I pick, Cosecant is 1 over sine minus 1, which is sine over sine. So 1 minus sine over sine is really that second whole thing. Now, if I pick carefully the tangent half angle identity, I could pick one that has 1 minus sine in it. So I could pick 1 minus, not 1 minus sine, right? 1 minus cosine over sine. I could pick the one with sine on top because then that will cross out. Let's do that. So I'll pick sine over 1 plus cosine. I'm going to pick that one. Sine over 1 plus cosine. So those cross out. I have 1 minus sine over 1 plus cosine equals -1 equals -1. I'm going to multiply this over to the other side. 1 minus sine theta is still here equals -1 minus cosine theta because I multiplied it with the -1. Then if I add 1 to the other side, 2 minus sine theta equals negative cosine theta. Now I'm dealing with one of those examples that we should square both sides and then use Pythagorean identity. How many minutes do I have? 6:50. Okay, so this might be the last one because I'm trying to not make a mess and I've already used a pretty decent amount of paper. So, okay. If I square both sides, 2 minus sine theta squared equals negative cosine theta squared. When you square both sides, you have to remember to check for extraneous solutions. That's something from algebra. Okay? Anytime you square both sides, you have to remember to check for extraneous solutions because squaring both sides does something to manipulate our equation and messes some stuff up sometimes. So 2 minus sine theta, 2 minus sine theta equals, that's just going to become cosine squared theta. Cosine squared will become 1 minus sine squared theta. Okay? So I'll have all signs. FOIL, I got 4 minus 4 sine theta plus sine squared theta. Then we're going to get everything equal to 0 and put it in descending exponential order. So I'm going to add sine squared and subtract 1 from both sides. I'm going to reorder this. If I add sine squared, I have 2 sine squared on the left. Minus 4 sine theta. 4 minus 1, so plus 3, equals 0. Now I'm going to factor this. But it doesn't factor. 2 times 3 is 6. Nothing multiplies to give me 6 and adds to give me -4, so I have to use quadratic formula. Instead of x equals, it's sine theta equals negative b is 4 plus minus the square root. B squared is 4, negative 4 squared is 16 minus 4a c all over 2a. Now 2, 4 times 2 is 8 times 3 is 24. So inside I get 16 minus 24, that's -8. You can't have a negative number under your radical, no solution. So whatever. All right. If it wasn't negative under the radical, you'd keep going and it would turn into a calculator question. However, you get a negative number under your radical, so it's no solution. That's enough for this video because it's about 10 minutes. And I'll pick up with the next example in the next video. Adios.